So today we're going to build on our picture of the atom, which we've been doing over the last few videos in the radioactivity series, but this time we're going to move on to describing how electrons are arranged inside the atom. This is what Niels Bohr did after Rutherford came up with his nuclear model, so today we're looking at the Bohr model of the atom. Electrons are arranged in shells or energy levels in the atom, but each shell can only contain a certain amount of electrons. The first shell can only hold 2 electrons in it, the second shell can only hold 8 electrons in it, and the third shell can only hold 8 electrons in it. After this, things do start to change, but we're not going to get into that. Electrons try to stay as far apart in the shell as possible because they're all negatively charged, so they repel each other. But they will pair up when there are no spaces to fill in the shells. In an atom, the number of protons always equals the number of electrons. For example, lithium has an atomic number of 3, so its atom contains 3 protons and therefore it has 3 electrons. Carbon has an atomic number of 6, so its atom has 6 protons and therefore 6 electrons. This is why atoms have an overall 0 charge, because the positive charges cancel out the negative charges. An atom can absorb energy. This is either from particle collisions or absorbing electromagnetic radiation. If an atom gains enough energy, it will lose an electron, and this is called ionization. When an atom has lost an electron, it will become an ion. We show ions by drawing square brackets around an electron diagram and putting a number and a plus in the top right corner. The plus sign shows that the ion is positively charged, and the number next to it shows how many electrons have been lost. If it's only a plus sign on its own, this means it's lost 1 electron. We don't need to put the number 1 next to the plus sign. Atoms can also gain electrons, and these form anions. To show this, you will put a minus instead of a plus sign because it's negatively charged now.